Yesterday, we learned law of cosines. I kind of went out of order. I don't know why. It seems like I always teach law of cosines first, and then I'll teach law of sines second. So, but they do it in the other order. So let's do the law of sines today. The law of sines. And this is another thing that you're going to have to memorize. So here's a triangle. And let's label this angle A, B, and C. Now remember, this is very important, especially on this one, for the law of sines, to make sure that you call the side that's opposite that angle the same letter, but a lowercase letter. So this is angle A. What's the side BC going to be? It's going to be little a, and this is going to be what? Little b, and this is going to be little c. All right? I should make my big C look a little bigger. Because the little c and the big C, they look the same, except one's bigger, right? But at least A's look different, right? And B's look different, so you can tell the difference between them. It's a weird looking B. All right. Let me just give you the formula. And some of you guys already looked it up, right? Okay, so I'm writing it a little different than they do. It actually doesn't matter, but this is how I've always learned it, and this is how I've always taught it. I write it like this. Little a, over the sine of A. Now they write it different. They put the sine of A on top, but it all depends on the problem. It all depends on what they give you on how I'm going to write this, but I'll just write the rest of it out. So you can switch it. Yeah, it doesn't make any difference as long as you switch the other one as well, okay? And then this is sine of C. Okay? That's how I write the law of sines. So put that in a little box and call it the law of sines. All right, now you know what the A and the A mean, right? Look, this is little a over big A. So what is this? This is side A, and this is angle A. Now remember, you can only take the sine or cosine or tangent or whatever trig function of an angle, right? So you can never take the sine of a side, S-I-D-E, okay? Everybody hear that? That's very important because a lot of people get confused and they'll take the sine of that number, the length of that side. You can't do it. You can only take the sine of an angle. Because what does it mean? The sine means you're taking that angle and then you're taking the opposite side, dividing it by the hypotenuse, right, of that particular angle. That wouldn't make any sense if you talked about the sine of one of the legs of the triangle, all right? So make sure that you understand that. So there's the law of sines. Now, even though there's three of them right here, we're not going to use all three of them. It just depends. We're going to pair them up. So it might be A over sine of A equals B over sine of B. Then you're just going to use that. Now, once you have enough information in there, what do you think you're going to do to actually solve? Cross multiply, exactly. So we're going to use that whole cross multiply method. Everybody with me on that? All right, let's put some numbers in. The best way to teach this is just by an example. So let's go ahead and do that. I'll keep the law of sines right there and put the triangle here again. And I'm just gonna try to make it look like, actually they're gonna flip that around, aren't they? Kind of. Doesn't matter. Let's reflect it about. There we go. That's good enough. I don't know. Does it look like it now? Yeah, it kind of looks like it now. That angle's a little bit bigger than what they have on there, but it's close enough. Excuse me. Sorry. Let's just. There we go. Sorry. A little picky. Let's put some stuff in here. This is 97 degrees. This is X. This is 21 degrees. And this is 16. All right. How do you know when you can use the law of sines and use the law of cosines? What did we say yesterday about the law of cosines? When can we use it? When it's what? Side angle side? Okay, good. Or what else? There was another one too. Side, side, side. Do we have either one of those? Not really. Now, you could find this angle right here very easily, couldn't you? That third angle. Just add these up, take them away from 180. So it looks like you might have side angle side, but the problem is I don't know what this side is, right? So I would need to know a side, know an angle, and know another side to be able to find like this third side right here. So really, it doesn't look like I can even use law cosines even if I wanted to. Does it? There's just really no way to use the law cosines with this. So I need another way, and that's the law sines. Let's tell you what. Let's scooch this whole thing right there. Let's put that right there so I can see it. I'm going to put that up like that. Is that better? All right, so what we're going to do is we're going to use one of these. It's basically this. If I know 3 of these 4 things, right? If I know 2 sides and 1 angle, or if I know 2 angles and 1 side, everybody hear me on that? I should be able to find the other one. Now, it's not just any old 2 angles. It's this side opposite its angle, right? And the side opposite its namesake, right? Across from B. You follow me? So what I'm going to do is this. I always need to have an angle and a side opposite that angle. I need to have at least one of these and one of these. Would you agree? Yes? Okay, so I need to have side A and an angle A that I actually know. And then one of these, they could either give me another angle, and then you have to find the side, or they have to give you another side and you have to find the angle. All right, so I always look to see if I have something across from each other. If I have something across from each other, usually I can use the law sines. And do I have something across from each other? Absolutely. So how am I going to do this? Well, if I'm solving for a side, that's why I like to set it up like this, because if I'm solving for a side, I'm going to put the side on top. What if I was solving for an angle? It's a little easier if I just put the angle on top. You'll see after we do a couple of these. So let's see this. Look at this side right here. What do I know? What else do I know? I know the angle opposite that, don't I? Everybody see that? So really what I'm looking for is I'm looking for a side and an angle opposite that side. And here I've got another side and an angle opposite that side. Does that make sense? Okay. If I have that, it's a great chance that you're going to use the law of sines on this. All right, so let's see what we can do. I'm trying to solve for x, right? I think it's easier to set it up like this. I'm going to go x over what? You always go across from it, opposite the sine of the angle that's opposite, 21 degrees. Set that equal to, take the other 2. Now look, if I went the side over the angle, I have to go the side over the angle here. So what's going to be on top here? 16 over what? Sine of 97. Good. Now you could cross multiply, but let me show you a little, not really a trick, but it's just an algebra step. You could cross multiply. Would you agree? But since x is already on top, what do you think you can do? That's right. Multiply the other side by just the sine of 21. And that's just one step and you got it, right? You don't have to cross multiply, and then divide. You save yourself a step by just noticing that what I'm solving for is already in the numerator. So really all I got to do is just multiply by the sine of 21. So I come over here and I multiply by the sine of 21. Wasn't that easy? That was nice algebra, wasn't it? And now I just plug that into a calculator and I'm done. Yep.
If it was like x was in the value, you just like flip the problem and then do that.
Exactly. You know what I would do though? I wouldn't even bother doing that. When I set up the problem, I'm always going to try to set it up with what I'm trying to solve for is on the top. It just makes your algebra just a little bit easier, okay? So I would just be a little bit more careful that you set it on the top. Now you could have done this. You could have said sine of 21 over x equals the sine of 97 over 16, right? And then you could have flipped them if you wanted to. Or you could have just cross multiplied right there and still got the same answer, right? There's a lot of different options on this. But to me, I think the easiest option is to see what you're solving for and just make sure that's on top. Does that make sense? Okay. So now we just plug this into a calculator. And I think I'm already, yep, I changed it earlier today. I'm already on degrees, so I'm good to go. So what do? We just go 16 sine of 21 divided by sine of 97. Pretty straightforward on a calculator, not that big of a deal. There you go, 5 point, let's say 8. What do they say rounded to the nearest tenth? What do they say? On the homework? Yeah, so we'll take this to 5.8. So x, whoops. So x is 5.8. We good? What if we wanted to solve, let's stick with this problem. What if we wanted to solve for y? Now we know what x is, right? It's 5.8. What if I wanted to solve for y? You can't just do Pythagorean theorem, can you? Why not? It's not a right triangle. Good. Okay. So what we could do is this, though. We could find this angle up here. Does it take much effort to find that angle? Not really. Just take it away from this. So what's that? Well, let's just do it on the calculator. Lazy. Me, I'm lazy. So what is it? 180 minus 97 minus 21. 62. All right. So that's 62 degrees right there. That wasn't hard. And now watch what we can do. This is just another good practice using the law of sines. Now you're trying to solve for y, so I'm going to put the y on the top. Everybody with me on that? So I'm going to go y over what? The sine of 62. Now you could do this. Now watch very carefully. A lot of people are busy working, and I see your heads down and you're working, so I'm not yelling at you for not paying attention, but do look up here. You could do this. Since you know this, you could say 5.8 over the sine of 21. I probably would rather not use that number right there. Why not?
Because it's not exact.
It's not exact, right? It's a decimal. It's not exact. So I would try to stick with the exact numbers as much as possible. So we've already got the two numbers over here. We used them before, didn't we? So I would go ahead and use those. Does that make sense to you? Now you're still going to get close. I mean, it might even round to the same exact answer, but there are times where it might round off just a little bit differently. All right, so I like to stick with the exact numbers as much as I possibly can. So 16 over the sine of 97. Now, to solve for y, what do? Multiply both sides by the sine of 62. Do you understand why I did it this way and didn't cross multiply? It actually saves you a little bit of a step, okay, to do it that way. So you throw that in the calculator and you see what you get. And let's just do it one more time so we can practice doing this. So it's 16 times the sine of 62 divided by the sine of 97. Sine of 97. And that's about 14.2. So y is approximately 14.2. And that would be this one right there. Let's see if that makes sense. This is the shortest side, isn't it? So it's opposite the smallest angle, isn't it? 16 is the longest side out of these, and then it's opposite the biggest angle. This is the in-between one, it's opposite the in-between one. So I mean it's not a fantastic check to guarantee that you got it right, but at least it tells you you're on the right track. Would you agree with that? Yeah. And I would do that every once in a while, especially on a test if you got time to go over it. I would just glance at it real quick just to make sure you didn't get something real funky, because I mean, I'm telling you, people get some crazy answers that don't make a lick of sense at all, and they still put it in there. Why? Because the calculator gave it to them. But guess what? They just put it in the calculator wrong. All right, so make sure the numbers make a little bit of sense before you write it down and circle your answer. Everybody okay with that? All right. Let's do one where you had to find an angle. Is that all right? I don't want to give your homework away. Let's do this one. I'm looking at a example here. I'm looking at page 583, example 2A. So let's do that one. Because the example's already done for you, I'll do one where they actually don't work it out for you. They just give you an extra practice problem. All right. It's 2A. Example 2A. And we're trying to find an angle this time. Yeah, you basically do it the same way. It's just the math at the end is just a little bit different. But this time we're trying to find an angle, aren't we? So instead of putting the side on the top, instead of A over the sine of A, how do you think I'm going to write this? The sine of whatever, in this case x. You follow me on that? All right, and you don't have to do it that way. I'm not saying you have to. I think it's convenient. I think it's a little bit easier for us to work that. So if I'm trying to solve for x, I want to put that on top. It's just a lot easier in your algebra to work with x when it's already in the numerator. So I'm going to put the sine of x over what? 14. Good, because you go opposite. All right. And now, do you know an angle and a side opposite the angle? Absolutely. So we're putting the angles on top this time, aren't we? So I'm going to put the sine of 63 over what? 12.5. Does that make sense? Now, I could have written it 14 over the sine of x equals 12.5 over the sine of 63. And that would have been fine. You could cross multiply and you're good to go. But this way, I think, is a little easier because all you got to do is one step. Just get rid of the 14. How do you get rid of that 14? Multiply by 14, right. And then, so where do I put that here? I'm going to put that right in front of that. That looks nice and concise and pretty, doesn't it? And now, we got to put this into our calculator. But you got to be careful. You put this into your calculator, this stuff right here, is that your answer, though? Is that your final answer? That's right. You got it. It's the sine of x equals this, so x has to be the what? Give me a good word that we've been saying. So x is equal to not the sine of all this stuff, it's the what? The inverse sine of all that. Exactly right. Everybody see that? Okay, so x is equal to the inverse sine of all of this. All right? So make sure you do that. Don't just leave this answer right here. Make sure you take second function sine when you put all that stuff in. So let's see what we get. And so it's 14 sine of 63 divided by 12.5. Okay, I'm going to hit equals right there. So that's not my answer, though, is it? All right, again, that doesn't make any sense. There's no way that that angle is 0.99 degrees, is it? So you're like, okay, I got to do something else. What else is it? Oh, yeah, I got to get x by itself, so I take the second function sine. So second function sine. On this calculator, what do I put in? The answer, right? You don't have to close it, but I'd like to. And then that equals 86.3. But they tell you to round the degrees, or the angles to the nearest degree, don't they? So what would this be? Be 86 degrees. So x would just be 86 degrees. That's all there is to it. Now, I'm not going to get into this, but there are some special cases. In Algebra 2, you'll get into this, okay? In Geometry, they just give you ones that work out every single time. And, oh my goodness, I had the word in my head, and now it's out of my head. It's called the something case. Oh, there it is. It's the ambiguous case. I'm going to write the word down. Ambiguous case. Now, in the geometry book, they're not going to give you a problem where you're going to get the ambiguous case. In Algebra 2, though, you're going to do the same stuff. You're going to learn law of sines, law of cosines when you get into Algebra 2, and they will talk about the ambiguous case. All right, so I'll just put it out there so that you hear the word, and when you get into whoever teaches you Algebra 2 next year, if they talk about it, you're like, yeah, Hamrick talked about that. He didn't tell us what it was, but he did say to look out for it. All right, if you want to look it up, there's good videos on YouTube. There really are, where they explain the ambiguous case, and they use they use programs very similar to what I have right here, and they do a good job of explaining it. So if you want to look up the ambiguous case for the law of sines, go ahead and do that on YouTube, and you'll get a nice little explanation of that. But in this geometry book, I don't believe, I'm almost positive, they don't give you any problems where that shows up. All right? So anyway, I just thought I'd throw that out there to you. All right, you guys said you had some questions on that law of cosine stuff again, right? So we will hit some of the problems from your homework on that one. So yeah, finish this up. Yep, do all the other problems for your homework. Yeah, but let's go over some law of cosines now since we got the time. All right. So give me a number that you had to do last night that bothered you. 25?
Yeah, just do 25.
Okay.
Well, they both have answers in the back, but
Yeah.
on our calculator, they
What's that? Yes, okay. Okay. All right, well, let's see what's going on. But you got other problems to work out fine? So it's not like every single one of these you got an
It was
error,
just
right?
like the last three where you actually had to find the angle.
The angle. Did you take...
I don't think you got an error. Because you had to do
I got
the inverse.
26 work.
And you did the inverse cosine?
All
All right.
I got it right.
Okay, here we go. Let's write it down again. Have you memorized the formula? Okay, so it's minus what? Good. All right. And this A, B, and C is arbitrary, right? It doesn't matter what letters you use. But what matters is this, that this represents the side, right? And this represents the angle opposite this side. And it doesn't even have to be the longest side. All right, it just has to be the angle opposite this particular side right here, and these are the other two legs. All right, so let's plug stuff in. So what do we got? We got 61 is what we're going to use, right? Because you're trying to find this angle. So that's kind of like our angle C, isn't it? So this will be like side C. So I'm going to go 61 squared equals, and these are the other two legs of the triangle. So 29 squared plus 50 squared minus 2 times 29 times 50 times the cosine of C. All right. Now, the hardest part about this is just getting C by itself. And we talked about this a little bit yesterday, didn't we? So let's write it all out. Let's do it all in one shot. What's that? Right. So, yeah, I mean, it's really 3 steps, okay? You subtract a couple things, divide by a couple things, take the inverse, and you're done. All right? So we subtract these 2 things. And I'm not going to write it out. I'm not going to, spend all afternoon plugging stuff into a calculator, okay? I'm just going to subtract them. Why did I put plus there? Somebody stop me. Thanks. Too late now. I already got run over. All right, so we subtracted these 2, so I got rid of that, didn't I? Now, how do I get rid of this stuff? How do I get rid of this? This is all being multiplied, so I divide it, right? So I divide it by -2 times 29 times 50. Now, that's equal to the cosine of C. So what do I need to do to this? Take the what? If I'm going to get C by itself, angle C by itself, that's right, I take the inverse cosine of all this. So it was a little bit of algebra, but I kind of did it kind of nice and neat. Wasn't that nice? I didn't have to show that all that stuff canceled out. I knew it was going to cancel out. So I just subtracted these 2, divided these 3, took the inverse cosine. That's the 3 steps I was talking about. Now the hard part is just putting it into a calculator. And I'm sure that most of you guys probably got to this point. Am I right on that? And then it's just a matter of doing it on the calculator. So let's see. Kind of messed up yesterday, didn't I? Well, it's just I punched the wrong button. I mean, I did everything. Oh, yeah, see. You did watch it? Oh, okay. So you heard my little... All right. So what do we got? 61. I tell you what, I'm going to do this. Let's clear it. What I'm going to do is this. Let's do this in another color here just so I can point this out to you. Watch. I am going to do this. In purple is where I'm putting parentheses in my calculator. I don't know, whatever it is. Watch. I'm going to put a parentheses here and here. Everybody with me on that? So the purple represents putting a parentheses in your calculator. And I'm also going to put parentheses here and here. Everybody see that? So I think it's very important to put parentheses where I put the purple parentheses. So let's try it. So we start off with a parentheses. We go 61 squared minus 29 squared minus 50 squared. 50 squared. And then I'm going to close that parentheses. Everybody good? Okay, now I hit divide. And I have another parentheses. And I hit -2 times 29 times 50. And I'm going to end that with a parentheses. Now I'm going to hit equals. And I get that number right there. Okay? Then I hit second function cosine of my answer. And then let's see what we get. There it is. All right, let's, yeah, did you use parentheses? You pretty much do exactly what I just did right here, and actually it's one less step, because you don't have to hit the answer, you don't have to hit the second function answer. Really, on that TI 30XA, it's really exactly what I just did right here. So parentheses, are you starting? Okay, so start off with the parentheses, and then do everything I did here. 61 squared minus 29 squared minus 50 squared, close that with the parentheses. You got it so far? It probably gives you some big number. Divided by, and then another parentheses, left parentheses. Now, on this calculator, you actually hit the negative first, then the 2. But on your calculator, you hit 2 first, then negative. Do you see that it made it a -2? And then you hit times 29, then times 50, close the parentheses. Hit equals. Uh-oh, what just happened? What happened? I didn't think I touched anything. It just went away. Then you get that negative whatever, whatever. Okay. And then Oh, there it is. Thanks. Yeah, you get that negative number right there. And then all you got to do is hit second function cosine and you'll get that answer. Perfect, right? So it says to round it to when it's an angle, rounds to the nearest degree. What would this round to? 98 degrees. So this would be, it's actually angle X, isn't it? Is 98 degrees. And there it is. That's about as hard as it gets right there. I think that's about the hardest type of problem you're going to get. Yeah, and I don't think it's all that hard, do you? Now, at first, when I show people this, they freak out a little bit about solving for the missing variable. And some people like to do this. Some people, and I don't know why you would want to do this, but some people do this. 61 squared, and then they get 3721. You know what I'm doing? Yeah, it might be a good way to check, or right, if you're getting some crazy answer, you're getting an error on the calculator, you might want to go through that. But boy, that's a lot of extra work, isn't it? Doing all that, right? Putting those numbers in and then subtracting them and putting in a calculator again and on and on and on. Oh, you're using your calculator 10 times as much as you really need to. I like to get it all done in one shot, right? Put it all together, do my algebra, put it all in one shot, and boom, get my answer. I think it's a little bit more streamlined that way. I do too. Right. Okay, we getting it? It could have been the parentheses thing. Maybe you didn't put parentheses. You did? Yeah, I on some of these, like on this one, you didn't even need it. You could have just said equals, right? I'm not sure if you need them on the bottom, but to tell you what, I just feel more secure knowing that I'm taking all that stuff, putting into parentheses, right? So it's grouping all that stuff together. It's grouping all this together. I know I'm dividing those two groups, and I don't have to guess how my calculator is thinking, right? I'm telling the calculator what to think, you know? And I like to be in control, right? And so there you go. It's like, it's like photography. I like the manual setting on my camera in photography and not the program setting, because the program setting just does what it thinks it should do. And sometimes the camera doesn't know better. Sometimes it works fine, but sometimes you got to be smarter than the camera. And I tell photography students that all the time. So it's the same thing with the calculator. So are we clear on this stuff? That's not so bad, is it? So now you know some trig, all right? Now you know some real good trig. And don't you feel smart now? All right. So let's see. I don't know what we're doing tomorrow, but just finish this up, okay? So just finish up that assignment I gave you yesterday. So what is it basically? 12 to something? 12 to 28? Okay. So it's 12 to 28. Make sure those are all finished. What is it? Page 587, right? All right. So just make sure they're all done. We'll turn those in tomorrow. And I don't think we should have to spend a lot of time on that tomorrow. Do you? I'll read them off. I'll read them off tomorrow.